Hello everyone, welcome back. So today's topic is going to be on implementation of queue using arrays. So I'll teach you what exactly is a queue, okay, what are the basic operations performed in queue and how to implement queue using arrays. Now coming to the basic concept of queue. What is queue? Queue is a linear data structure. So it is a linear data structure where the operations performed in queue follows the rule FIFO, which is first in, first out, or it is also called as last in, last out. Okay, so first in first out means the element that is inserted first will be deleted first, or the last element that is inserted will be deleted last. So this is a concept. When compared to stack, stack is first in last out, right? That is last in first out. Last in first out means the last and third element will be deleted first in case of stack. Hmm? Fine. Okay. The operations that are performed in case of queue, if it is insertion operation, then it is called as NQ operation, and if it is deletion operation, then it is called as DQ operation. Okay. But in case of stack, both insertion and deletion will be done through one end, whereas in case of queue, it is done using two different ends. So I've written a note here. So queue principle is insertion and deletion are done at different ends. Okay, either it can be through this end or this end. So insertion, what my assumption here is insertion will be done through insertion is done at the insertion is done through one end and deletion is done through at the other end. Okay, so now as per the assumption that I've taken, insertion of elements will be done through the rear end. Okay, so this end, and deletion will be done from this end. So whatever element is inserted through this end, first it will come in place at index 0, then 1, and so on. Okay, so now I'm using two variables, front and rear, both initialized to -1. So when both are -1, which means q is empty. Fine. When both the variables are -1 initially, then it is empty. See the note here. Q will be empty. Initially, Q will be empty. Front and rear variables are initialized with value -1, indicating that Q is empty. Okay, this is the first point. The second point, I'm using two variables here, rear and front, where insertion is done using rear variable and deletion is done using front variable. Now see the second point. Insertion is done through rear and deletion is done through front end. To insert first value, please understand, initially when the queue is empty, both rear and front values will be -1. So when I want to insert the first value, before insertion, what we have to do, first increment front and rear by +1. So both the values will be incremented by 1 and the values will be changed to 0 from -1. Now both the variables are pointing to the first element. Then initially after implementing front and rear variable, when I invoke NQ of 10, which means I'm passing the argument here 10. Okay, when 10 is called, what will happen? The value 10 will be inserted. So rear, through rear variable, I'll insert 10. Okay, it will q of rear is equal to 10, the value that is read. Okay, now see this rule. Initially, when the queue is empty, both front and rear variable will be, the value will be equal to -1. Then in order to insert first, I have to change front and rear variable values to 0 and then only insert the first. And henceforth, see the third point, if I wanted to insert another next element, that is 20, in at a position, index position 1, what we have to do, keep the front variable as it is. Front will still be pointing to 0, 0th index. Okay, increment only the rear. Here previously first element rear was 0. Next increment rear variable by 1 and then insert 20. Third element, if you want to insert, increment rear variable, then insert 30. Fourth variable, if you want to insert, call NQ of 40, call the function NQ of 40, insert 40. Okay, by after incrementing rear only you can insert 40. Okay, without increment rear variable, if you insert 40, 30 will be replaced by 40. So first step, in order to insert, increment rear variable and then insert the values. Now see the next point, NQ of 50, invoking NQ of 50, what will happen? 50 will be inserted, rear variable will be incremented and 50 values inserted. Now see the next point. To insert the sixth element, invoke NQ of 60. Right now I'm invoking NQ of 60. What will happen? Since the element, I've assumed the maximum size of element Q should be 5. This is an assumption. How many elements we have inserted? 10, 20, 30, 40 and 50. So 5 elements are already inserted. What is current variable value of rear variable? 4. Okay, now in such case, if you are trying to insert one more variable 60 after 50, there is no room for 60 to be inserted. So what is this condition called as? Queue overflow condition. So when the queue is full, And if you try to insert at this point, you will get a message called queue overflow, where you cannot insert any variable. Okay, so this is how insertion works. How exactly insertion works? First step you have to remember, initially you're making your two variables, rear and front, both the values are -1. To insert the first element, that is first point. Okay, second point, to insert first element, change rear and front variable to 0, which will be pointing to the first index, and then insert the first element. And henceforth, if you want to insert the other elements into the queue, keep front variable as it is, which is pointing to the first element, increment rear variable, and then insert the value. So first increment and then insert. Okay. And the last point for insertion function is, once after inserting all the elements into the queue, okay, once rear has reached the maximum limit, if you try inserting any variable value into the queue, element into the queue, it shows a condition called queue overflow condition, which means queue is not empty. Okay, now let's move on to the next one. DQ. What is DQ? Deleting an element. So what did I say? Now see here, see this diagram. Rear will still be pointing to the last element. Okay. Now I wanted to delete 10. In order to delete 10, just increment front variable. Just front variable is incremented by -1, which means now front variable is pointing to the second element. This is an indication that the first element is deleted. Now the top of the queue will be 20, 30, 40 and 50 henceforth. Okay. So next time when I invoke DQ, second element will be deleted by incrementing the front variable. Next DQ, now third. Okay. Now just assume, now please understand, this is very important point. How many elements are deleted in the queue? There are 3 elements deleted in the queue, right? Leftover elements are 40 and 50. Now if I want to perform NQ of 60, which means what is NQ? Inserting 60 into the queue. Okay, there is a room in order to insert 60, but since rear is pointing to the last element, what is the condition? You will get queue overflow. You cannot insert 60 even though there are empty spaces in the queue. This is one of the disadvantage of queue. How to overcome this disadvantage? It is done using circular queue. So circular queue is the solution for this. Got it? Any doubt? Okay, so this is how insertion and deletion is done. To insert, increment only rear variable. To delete, increment only front variable. Okay, now I'll teach you the implementation part. Now see the implementation part here. I have already done the coding part. Let me teach you this. Okay, now these are the basic steps. Within the class name is Q operations. I'm just doing it in the online compiler. Okay, so the file name and the class name should be same. So Q operations.java. Let me teach you what variables I'm using in this program. I'm using rear, which is initialized to -1, front is equal to -1. So -1 is an indication telling both are pointing to the first, pointing to the starting point of the queue. So rear is equal to -1, front is equal to -1, and Q, this is an array. This is how you declare an array. Okay, Q of is equal to new int of 5. What is the maximum size? 5. Okay. Then I'm using variable value. Thus, variable value is mainly used for inserting element into the queue. Later in the program, I'll tell you why I'm using these 3 variables, ch, I, and choice. So now you're clear. Rear variable to insert, front to delete, and value is to read input from the user. Q is the array name. This is how you declare. And what is the maximum size of the array? It is 5. Okay, now I'm using a scanner class. So you know what exactly is scanner class? To read input from the user during runtime. Okay, then I'm asking, prompting the user, enter a value. So before going into the enqueue, let's call the main function. So after the class, we'll have the main function. So in the main function, I'm using one more scanner class, then an object obj in order to invoke function. So what are the 2 functions I'm using? Enqueue, dequeue, and display. Okay, enqueue, dequeue, and display. Enqueue is for insertion, dequeue is deletion, and display is for traversal. The first line that will be displayed is implementation of queue operations. Okay, now I'm using the variable ch. What is the ch? And I've initialized it to 1. So what does this 1 indicate? This is mainly for looping, which means invoking the function enqueue, dequeue, and display during runtime. Again and again, I'm putting this in loop. Okay, and I'm using a menu-driven concept using switch case. Then it will enter, since ch is equal to 1, it enters the loop. Enter your choice. So now it's asking to enter this choice. What is it for? What is it actually displaying? See, this is the implementation of queue operations. Enter your choice. So it is 1, 2, 3, 4. Okay, this will be displayed once these lines are executed. Now if I enter 1, which means I'm opting for enqueue operation. So what is enqueue? It is insertion. Now it will come here. Choice. Once I press 1, that 1 will be stored in choice variable. Now you got it. Ch and choice variable, why I'm using switch of choice. Now what is choice value? 1. So it will come here. Since it is case 1, there is a match. Now it will invoke obj.enqueue. What is enqueue? Enqueue is a function call. So from line number 76, control will go to the main function definition for enqueue. Now it will come to line number 5. From 76, it jumps to line number 5. So in line number 5, I'm using one more scanner class because I'm trying to read values to be inserted. Okay, then I'm using the value variable. So the value that is entered during runtime will be stored in the variable value. Now see here, if rare is equal to 4, what is this condition? After inserting, just recollect the image there, 10, 20, 30, 40, 50. What was rare pointing variable? It was pointing to 4, right? Rare was pointing to 4. So I'm checking. If my stack is full, this condition is used to check whether stack is full. I'm sorry, queue is full. Okay. So this is used to check for queue is full. Okay, if queue is full, what I have to do? Print queue overflow. So the first condition before inserting, we have to check whether queue is full, because if the queue is full, we need not insert any value. Okay, then else if there is a second condition, what is the condition? If front is equal to -1 and rear is equal to -1, what is this condition? I'm checking queue is empty. If both are pointing to -1, then queue is empty, right? Then what is the condition? What is the condition I told you? To insert the first element, please note, to insert the first element, you have to make front is equal to 0, rear is equal to 0. Now both front and 0 are pointing to the first index. Okay, and then whatever value you have to write, you're storing it in queue of 0. So initially here it will store the value will be stored in queue of 0. First value will be stored. What was the first value we entered? 10. Okay, then otherwise for the first element, what we are checking whether queue is full, and second time we are checking whether queue is empty. If it is empty, we are trying to insert first value, and then after entering the first element, the other elements, what we have to do, we have to only increment the rare variable. So rare is equal to rare plus 1. Now initially after inserting first value, what is rare value? Rare is equal to 1. Okay, and then second value that you enter will be stored where? Queue of 1. Q of 1. What is Q of 1? If I'm giving entering the input 20. So Q of 1, 20 will be inserted otherwise. Okay, again it will go back. After entering third, rare will become 2, 2. Then Q of 2 is equal to the third element will be 30. Got it? So this is how you perform insertion in case of Q. Very simple. You have to check three conditions. What are the three conditions? First one, when Q is full, print overflow. Otherwise, check Q is empty. If it is empty, change the value of front and rear values, variable values. Then insert the first value. And after that, subsequent entries within the queue will be done by incrementing rear variable and then storing that value into the queue. Okay. Now, after performing insertion, come to the main function. What is the next one? obj.dq. Now it's invoking dq function. So this is dq function. So it moves to line number 27. What is line number 27? First it's checking if rear is equal to -1 and front is equal to -1. What is this condition? Q underflow. It's checking whether Q is empty. Then it throws message Q underflow. Else if front is equal to rear, when you have only one element, it checks only if Q, only one element is present. Only one element present in Q. So when you have only one element present in queue, this is a condition check. What will happen? You're popping or you're deleting that element. You dequeue that element. Then you're making front and rear to be -1. 10, 20, 30, 40, 50 is the last element, right? After deleting 50, okay, immediately we have to make front and rear to -1, which means this indicates this is used to show queue is empty after deleting last element, correct? Okay, so this is how it shows that front and the queue is empty after deleting the last element. Understood? Otherwise, first one, queue is empty. Otherwise, only one element is present in the queue, the last element. If not, you have multiple elements into the queue. What we have to do, increment only the front variable by printing which element you wanted to delete. First, you have to print and then you have to move the front variable, increment the front variable. Okay, so this is dequeue function. The next task is display, that is traversal. So what is traversal? First, we check if rear is equal to -1 and front is equal to -1. If the queue is empty, obviously no elements will be there. So we only print queue is empty. Okay. Otherwise, elements of the queue are. So starting from where? Starting from front. It should not print in the reverse order. We have to print from the first element that was inserted, 10, 20, 30, 40 and 50. So I is equal to front, I less than or equal to rare until a rare variable, because the rare variable will point to the last element in the queue. So we put in the loop and we print the queue elements. So that's it. And finally, case 4, if you want to continue, you can press 1, otherwise 0, which will be stored in variable ch. So this is how queue operations will be performed. Okay. Now let me tell you, value is a variable used to read the current value that should be inserted into the queue. Rare and front variables are used for insertion and deletion. Queue is the array name. Ch for continuing the execution, to display NQ, DQ and traversal, make you to call multiple times the switch case. I is for iteration. Choice is to choose between the operations of the queue. Okay, clear? Okay, now let's move on to the execution part. Let me run the code. Okay, it's asking for first choice, so I'll enter first. It's asking for the choice, I'll enter NQ. NQ is insertion, so you give 10, enter. Now 10 is inserted. Let's check for traversal 3. See, 10 is inserted here, right? Again, I'll give NQ1, enter the value to be inserted. Now I'll give 20, enter. Okay, then I'll again give 1, enter the value, again give 30, enter. NQ 40, fourth value, again 1, I'll give 50. Now again I want to see 5 values I've inserted. Now I'll give NQ1, plus for the value I'll give 60. Should 60 be inserted? No, because all 5 entries are filled, right? Now if I give 60, you'll get the output as queue overflow. Now let's check whether elements, third option, traversal. See, the elements of queue are 10, 20, 30, 40, 50. 60 is not inserted because this is the overall maximum size of the queue that I have chosen. Okay, now it's asking for the choice again. Now I'll give 2 DQ. So element deleted is 10. 10, 20, 30, 40, 50. First inserted is 10. So I'll get the element 10. Now give 2 DQ. 20 is deleted. 2 again. 30 will be deleted. 2 choice 2. 40 will be deleted. Choice 2. 50 will be deleted. Correct. All the elements are deleted. Now I'll give choice 2. You'll get queue underflow because no elements. All the elements are deleted. To check that, let me give 3 options. Queue is empty. No elements in the queue. Okay, so this is the execution part of the implementation of queue using arrays. Now I'll give choice 4, exit. Now it will ask enter 1 to continue or 0, 1. It will again go back to NQ, DQ and traversal option. If I give 0, it will come out of the execution. Okay, so I hope you understood the execution part and the basic concept of queue using arrays. Thank you.